Hello everybody. The experiment we will be doing now is the speed control of a DC motor. This is a DC motor we are using, and we are controlling the speed of this DC motor by using this SCR TYN604. This is the SCR we are using to control. Here we are going to vary the speed by controlling the conduction angle of this SCR. The conduction angle is varied by using this R and C component. By varying this R value, the charging time of this capacitor is varied. Thereby the conduction time of this SCR is varied. If the conduction time is varied, the voltage coming to the armature of this motor will be varied and the speed will be varied. If R value is more, the time taken by the capacitor to charge will be more. Therefore, the conduction angle of this will be, the conduction time of this SCR will be less. Alpha will be more, so the conduction time will be less. Therefore, the average voltage or the voltage that is coming to the armature will be less here. Therefore, the speed will be less. If R value is, that is the resistance, this pot resistance is less, capacitor will get quickly charged, alpha will be less, this will conduct quickly, the conduction time will be more voltage will come to the motor, therefore the speed will be more. Using this RC component, we will be varying the conduction time and thereby varying the voltage here and thereby varying the speed. See, this is the pot, this is the waveform across the motor here, and here across the motor we are connecting a diode. There is a diode connected here. This diode is connected to give a circulating path for the energy stored in the inductance of the armature winding. This is the output waveform across the motor. Because we are only doing it for a single, we have used an SCR, single SCR here. It will be conducting only for when it is forward biased. In the reverse biased it is anyway off. So we are only getting one half of the input. The other half, during the other half, the SCR is off. So output is not seen. This is only half rectified. This is the voltage across the motor. As I am varying the pot, you see, as I am varying the pot, the alpha, that is this blank space is nothing but the alpha here, this is varying. As alpha is more, we see the voltage now, alpha is more, the voltage is around 2.7, alpha is less, the space is less, the voltage is around 3.2. So it is inversely proportional to the alpha here, and this speed is directly proportional. See, alpha is less, speed is more, voltage is more. Now I will check the speed by using a tachometer. We are seeing the speed of the motor here, and the speed is around, see, the speed was around 700. The speed is around 735. Now suppose I vary the pot, I increase, the alpha will be more, voltage will be less. Now we will see the speed. We see the speed has reduced to 600, from 700 it has reduced to 600. So as I am varying the alpha, varying R, alpha is varied, voltage is varied and speed is varied. Therefore, by varying the firing angle using R and C of an SCR, we can control the voltage across the motor and thereby the speed of the motor. And using these values, if you are taking the values, we can plot the graph across, that is firing angle and voltage, speed and voltage, we can plot the graph of the motor. Thank you.